This is John Black, super chemist. We're going to define what an inertial frame is and an accelerated frame. This is one of the biggest problems in physics, this woke lies. We all know 100% of everyone agrees that if you are floating in outer space, right, there's no planets around, you are in an inertial frame. You are floating, you let go of a ball, it floats. Okay. And we also, everyone agrees, all inertial frames, right, have the same physics results, the same physics laws. Right? Now, this is literally the definition of an inertial frame. It's a frame where the simplest physics and the simplest math take place. You're moving at a constant velocity in a straight line. That's literally that's the definition. Okay, we're going to broaden it here so that you can understand. Okay, and keep in mind, constant velocity and standing still, it's the same thing. So we all know though that the floating man in outer space, this is inertial, and we all know that all inertial frames have the same physics, right? How can they all have the same physics? Because they all have the simplest physics. You hold a ball out, right, and you let go of the ball. If the ball accelerates somewhere, you're in an accelerated frame of reference. If the ball, this is called the floating ball test. If it just floats there relative to you and it doesn't accelerate off somewhere, then you're in an inertial frame, right? So if all inertial frames are the same physics, and this floaty man out in outer space is an inertial frame that we all agree on, everything floats in this frame of reference. The physics results you get when letting go of the ball is the ball floats. If all inertial frames have the same physics, then we can add it to our list describing what an inertial frame is. First, it's the simplest physics, simplest math. Everything floats. And that goes with our simplest math and simplest physics, right? Because if it doesn't float and it just accelerates away somewhere to some ground or something, that means the physics and the math are going to be more complicated than in outer space. Therefore, it's not the simplest physics, it's not the simplest math, so therefore it cannot be an inertial frame. Okay? What else do we know about this floaty man? We know that nothing accelerates to the ground in his frame of reference. Nothing. So that means if all inertial frames have the same physics, that means all inertial frames, nothing accelerates to the ground. So we add it to our list, right? Add it to our list. Nothing accelerates to the ground. In this floaty man thing, nothing is stuck to the ground. Nothing. Everything is floating, right? So we add that to our list. Nothing is stuck to a ground, right? So all inertial frames have these, they all have the same physics, then they have to have this list of things, right? So what about, there is no ground. When you're floating in outer space, there's never a ground. You can never refer to something as a ground. There is no ground, right? So if there's no ground in the floaty man, then and all inertial frames are the same, we add it to the list. There is no ground in inertial frames. There is no up and down with this guy. Why? Because there's no ground. There's no ground, there's no up and down. Up and down has to do with ground. Okay? So we add it to our list because all inertial frames have the same physics. There is no up and down. There is no gravity, right? That's why there's no up and down and there's no ground, because there's no gravity, right? So we add it to our list. There is no gravity. And we already know that you got to be going standing still / constant velocity in a straight path, right? So now we have our list of things that are true in this inertial frame that we all agree is an inertial frame. And we all agree that all inertial frames have the same physics. So every inertial frame will have these things. This list here, what is there, 9 things there? Okay? They will have all of them. You can't have an up, you know, you say, well, like there is no ground, there is no up and down. That means the same thing. There is no gravity. That means the same thing. Nothing is stuck to the ground. All these things mean the same thing. Everything floats means the same as nothing accelerates to the ground. And that means there is no, the same as there is no ground. It means that, you know what I mean? All these, number 3 down to number 9 is basically saying the same thing. You have the simplest physics and you have the simplest math. That's all 3 to 9 says. That you have what's the simplest math and the simplest physics? Everything floating. What's the simplest math and physics? Nothing accelerates to the ground. Nothing is stuck to the ground. There is no ground. That's the easiest physics and the simplest math. There is no gravity. Yeah, of course. Because gravity adds a lot of math and a lot of physics. So obviously you can't have that, right? Constant velocity in a straight line. There's the simplest physics because it's like you're standing still. Okay? Now what is an accelerated frame? An accelerated frame is just the opposite of all the traits we just named for an inertial frame. So an accelerated frame has not the simplest physics, not the simplest math. Nothing floats. Everything accelerates to the ground. Everything is stuck to a ground. There is a ground. There is an up and down. There is gravity. And there is acceleration. There's constant velocity in a straight path? No. Let's go over to 3 types of accelerated frames of reference that you can be in. Number 1, right? You can be in a spinny thing down here. Like you see here? And you can see there's a ground. Everything is stuck to the ground. And when you drop something, it accelerates to the ground. Okay? Doesn't just follow a constant velocity. It accelerates to the ground. Same with this, right? Because you have gravity. You know, you have gravity here. You make it by spinning around. Here you make gravity by accelerating up. You know, making your velocity more and more and more. Here you're changing your velocity. That's how you accelerate. The spinny thing, you're changing your velocity by changing your direction. See, direction is a vector. See, that includes direction and speed. So you accelerate here with the spinny thing by changing your direction. Here you accelerate by changing your speed. But speed and direction are both a part of the same thing, which is velocity. Okay, so they're both accelerating. Everything's here too on Earth. And you have gravity. You have gravity in both of these places. Same way with Earth. You have a gravity. You're stuck to the ground. Things to accelerate to the ground. You have an up and down. You know what I mean? Do you see how they're all the same? Everything accelerates to the ground. Everything. See how they all have gravity, right? All 3 have gravity. Not the simplest physics, not the simplest math. Nothing floats. Everything accelerates to the ground. Everything is stuck to the ground. There is a ground. There is an up and down. There is gravity. And things don't move in a constant velocity in a straight path. They accelerate down to the ground. See how these all have all those things in common. And what about this guy? He's floating. Where's my finger? He's floating. He has simplest physics, simplest math. Everything floats. Nothing accelerates to the ground. There is no ground. There is no up and down. There's no gravity. You're just standing still or moving at a constant velocity in a straight path. This is your inertial frame. To say that Earth is an inertial frame when you can have an infinitive number of these machines, just make them bigger sizes, bigger sizes, bigger sizes. You can have an infinite number of them, all accelerating with 9.8 meters per second squared, having all the same physics that you have on Earth. Same with this ship. You can have an infinitive number of these ships accelerating at 9.8 meters per second squared. And all the physics on this ship will match up to all the physics on the Earth. So Earth physics matches, right, has the same physics as an infinitive number of these accelerated things and an infinitive number of these accelerated things. And you can think in your mind of an infinitive number of people floating in outer space, not near any planets, and they're all on Earth. So there's an infinitive number of floaty guys that are inertial, and Earth does not have the same physics as an infinitive number of those floaty guys. But it does have the same physics as an infinitive number of these and an infinitive number of these accelerated frames. Obviously, it's an accelerated frame. I don't know how these people define. If someone disagrees with me, please tell me, what is your definition of an inertial frame? Because if you say, oh, all the people have the same physics and the same, like in Earth, well, if you drop a ball, you get the same physics. Even if you're in a car going at constant velocity, you drop a ball, you get the same results. Same with a plane. You drop a ball, you get the same results, 9.8 meters. Same on here, though. If this ship was big enough to drive a car and fly a plane, he would drop a ball in all three situations and get the same results as you get on Earth. Same way with the spinny thing. So you can't say that, oh, well, you get the same results. You get the same results here. You get the same results here. Both of these are accelerated frames. So obviously this is an accelerated frame. I cannot believe that I have to argue about such an elemental part of physics that it's almost like arguing 2 + 2 = 4. Everyone's telling me it's 5. Now you got 4 things here. Which one of these things don't belong?
One of these things is not like the others. One of these things doesn't belong. Can you tell which thing is not like the other by the time I finish this song?
You got 3 things over here. These red ones, they have 0 acceleration. Nothing sticks to the ground. Everything floats. Here you have everything accelerates at 9.8 meters per second squared down to the ground. Everything that you are not holding, it's already touched to the ground, is accelerating down to the ground. Nothing floats.
One of these things is not like the others. One of these things doesn't belong. Can you tell which thing is not like the other by the time I finish this song?
Yeah, because this is accelerated frame of reference and these are inertial frames of reference. Okay, here you got 4 things. You got a thing spinning around so that you get 9.8 meters per second squared. Simulated gravity. Here you get rockets going at 9.8 meters per second squared, simulating gravity. Here you got everything accelerating down because of gravity. Gravity is accelerating space-time down. Here so the space-time is accelerated through you, you know what I mean? So anyways, and here you have floating in outer space, right? Over here you have a ground. All 3 of these have a ground, right? They all have an up and a down, don't they? Everything accelerates to the ground. Everything accelerates to the ground, right? That you drop. Or if it's not accelerating to the ground, that's because it's already attached to the freaking ground. Yeah. So everything in these 3 frames is either accelerating to the ground or is stuck to the ground because the ground is accelerating and now they are accelerating. And the 0 floating. No one floats in any of these, okay? This one over here, you got 0 acceleration. Nothing, everything floats. There is no ground. There is no up and down, okay? There's only up and down in accelerated frames, right? So, which of these frames of reference do not belong?
One of these things is not like the others. One of these things doesn't belong. Can you tell which thing is not like the other by the time I finish this song?
Which of these frames of reference do not belong? Right. This one don't belong because it's an inertial frame, and these are all examples of accelerated frames. How do we know? Because they have a ground. Every accelerated frame has a ground. It has a